Assalamu alaikum wa rahmatullahi wa barakatuh. Hi everyone, nice to meet you all. Today inshallah we will complete in stereo-isomerism the first type of stereo-isomerism, geometrical isomerism. If you want to know any information about structural isomerism, including chain isomerism, positional isomerism, functional isomerism, you will find its complete information in the video of structural isomerism. Let's start with the first type of geometrical isomerism, cis and trans isomerism. At first, geometrical isomerism, cis and trans isomerism, we must have compound including double bond. To have geometrical isomerism, we are talking about alkenes. We must have alkenes. We can't have geometrical isomerism in alkanes or alkynes. So we are talking about alkenes or cyclic compounds, but at most in alkenes. Structure of our alkene must be RCH, double bond CHR. So we have carbon atom attached with hydrogen atom and alkyl group or aryl group, alkyl or aryl, okay? And the other carbon is the same, attached with hydrogen and alkyl or aryl group. Aryl group is the phenyl ring, benzene ring, okay? Exists as cis and trans isomerism if we have two R groups. The two R groups are not attached to the same carbon atom, and we will know why. Of the double bond, so the two R groups must be attached to two different carbon atoms. The first carbon atom attached to one R and the second carbon atom is attached to another R. And trans if the two R groups are on the same direction. So if we have two alkyl group on the same direction, we have cis isomer. If we have one alkyl group in the opposite direction with the other alkyl group, so we have trans isomer. Let's have many examples to understand what is the meaning of cis and trans isomerism. We have specific rules for knowing the geometrical isomerism. At first, we must have restricted rotation in our molecule. Restricted rotation, to have restricted rotation, we must have alkene or we must have another compound, cyclic compound. We must have two alkyl groups non-identical. Two different alkyl groups are attached to the double bond carbon atoms. You will understand it more and more with examples. The first example, we have butene, but we have cis butene and trans butene. In the first one, cis butene, we have two carbon atoms, 1, 2. The first one is attached with methyl group and hydrogen atom. The second one attached with methyl group and hydrogen atom. So, we can say that if the two methyl groups are on the same direction, we have cis butene. If the two methyl groups are in different directions, so we have trans butene. So we can have cis and trans, but our rules are in the compound. The first rule, we have restricted rotation. We say to have restricted rotation, we must have double bond, we must have alkene. The second one, we have two non-identical groups. On the each double bonded carbon atoms, we have two non-identical groups. We have two different groups on each carbon atom. Okay? The second one, we have 1 and 2 dichloroethene. In the case of 1 and 2 dichloroethene, we have 2 chlorine atoms attached to ethene compound. The first one attached to the first carbon atom and the second one attached to the second carbon atom. So, at first we have the two rules. First one, we have restricted rotation, we have alkene, we have double bond. In the second one, take care, we have two non-identical groups on each carbon atom. So, if the two identical groups are in opposite direction, we have trans. If they are in the same direction, we have cis. The third example is our compound, but we start show it just by different colored balls. The first one, we have restricted rotation, we have double bond. The second one, we have two different colored or two non-identical groups attached to the carbon atom. The first one is represented by the yellow pole, the second one is represented by the green pole. So we have two different groups attached to the carbon atom. According to having different groups, if they are on the same direction, we have cis. If they are on the different direction, we have trans. The next example is showing the cyclic compounds. We say that the cyclic compounds can have cis and trans isomerism, but it is less common than the alkenes. In the case of cyclic compounds, we have cycle. Our cycle is the cyclopropene. So we have cyclopropene. In each side, we have two non-identical groups. One hydrogen atom and one methyl group. One methyl group and one hydrogen atom. If the two alkyl groups are on the same direction, we have cis isomer. If they are on different directions, we have trans isomer. Our isomers are different from each other in their boiling point. Take care. If the alkyl groups are on the same direction, we have two bulk groups. We have two large groups on the same direction. So we have steric hindrance. We have unusual effect in the compound. So it will increase the boiling point and melting point for the compound related to the type of intermolecular force of attraction, related to the type of force of attraction inside your compound. So in the case of cis, we have 37 Celsius as boiling point. In the case of trans, we have 29 boiling points. So we will transfer to another example. In the first example, we have compound, but it is alkane. It is saturated compound. All of our bonds are single covalent bonds. Take care, the single covalent bonds, we have free rotation. It is easy for the compound to rotate. According to having the free rotation, it is impossible to have cis and trans isomerism like our doll. In our doll, take care, we can make rotation for the doll. As we can make rotation, if I rotate it completely, you won't recognize any difference, right? It is exactly the same. We have free rotation. But in the case of humans, I can't rotate completely. So just by rotating, we have restricted rotation. You will start to know that we have difference in the human. But in the case of dolls, we have free rotation. It is the same in organic compounds. In the case of the alkanes, we have single covalent bonds. As we have single covalent bonds, we have free rotation. Just by rotate the compound, we will have the same structure. There is no ability to know any difference in the compound. It is completely in free rotation. So we have free rotation, we have no isomerism. But in the case of trans isomer, we have restricted rotation. It is impossible to make rotation. If I make rotation in the alkenes, we have new compound. We transfer from cis to trans or from trans to cis. So we have no rotation, so we have isomers. We change the compound. Okay? Let's complete together. In the case of the single bond, there is flow rotation. According to the free rotation, take care, we have different physical properties. These different properties is rising from the change in the arrangement of the bulk groups. I explained it in the last slide. In the second one, take care, there is no geometrical isomerism. If we have this point and this note is very, very important. If I have CH2 double bond C, take care, we have no geometrical isomerism. Why we don't have geometrical isomerism? Because exactly we have two identical hydrogen atoms attached to the same carbon atom. So if I make rotation, it will be the same. In the second case, if I have C double bond Cr2, we have no geometrical isomerism because we exactly have the same alkyl groups are attached to the same carbon atom. So of course we have no geometrical isomerism. Okay, we will see the structure. In the first one, we have two hydrogen atoms. Start to rotate it, it will be the same. So we don't have any cis or trans isomerism. In the second one, we have two hydrogen atoms. So it is the same. And it is exactly if we have C double bond Cr2, we are talking about the same compound. Okay? Let's transfer to the second one. We have the following question. He starts to ask you, which compounds can exist as cis and trans geometrical isomerism, and draw them. We have four compounds. Take care, in the video I will give you one example and I will answer it. In the next slide we have some questions. Try to answer it at home. If you have any hard questions, write your questions in the comments and I will answer it for you. Okay? In the first compound we have CHCl double bond CHPr. Do you expect we have geometrical isomerism or we don't have? Let's look for the two rules. The first rule, we have restricted rotation, we have double bond. The second rule, each carbon atom is attached to two non-identical groups. We have carbon atom attached to hydrogen and chlorine, and the other one attached to hydrogen and bromine. So, of course, we have cis and trans isomerism. Let's have the answer together. At first, we follow the two rules. So, in the first compound, we have chlorine in front of bromine, so we have cis isomer. In the second one, we have chlorine in the opposite side with bromine, so we have trans isomer. Let's transfer to the second one. In the second one, we have CH2 double bond CPrCH3. Let's follow our rules. The first one, we have restricted rotation, we have double bond. It's okay. The second one, we have two identical atoms attached to the same carbon atom, H2. So we don't have the second rule. So of course we don't have cis and trans isomerism. Like our example in the last slide, when we rotate the compound, it will be the same. Let's transfer to the third example. We have C attached to two methyl groups and CH2CH3. Do you expect we have cis and trans isomerism? Let's follow our rules. At first, we have restricted rotation. We have C attached to two methyl groups. So we have at first restricted rotation. Second rule, we must have two non-identical groups attached to the same carbon atom. So we need to have two different groups. In the first carbon atom, we have two identical groups. We have two methyl groups. As we have two methyl groups are attached to the same carbon atom, of course, we don't have cis and trans isomerism. So it's our answer. It is filled to follow rule 2. The two alkyl groups are on the same carbon atom. In the last example, we have C attached to hydrogen and methyl group, and we have carbon attached to hydrogen and ethyl group. Let's follow our rules. The first one, we have double bond, so we have restricted rotation. The second one, we must have two non-identical groups attached to the same carbon atom. In our compound, we have hydrogen and methyl, so they are different. The second one, hydrogen and ethyl, of course they are different. So it follows the two rules. Let's have the answer. We have in the first one, methyl group in front of ethyl group, so we have cis isomer. In the second one, we have methyl group in opposite direction with ethyl group, so we have trans isomer. At last, it's your homework. Start to answer the homework at home. If you have any hard questions, just give me comment or give me any reply on the comments in the following comments, and I will answer it for you. Thanks for watching our video. I hope you understand our topic today. I think it is a small topic, and in the next video, inshallah, we will complete in the types of optical isomerism and types of chemical reaction. Thanks for watching our video. Don't forget to make like and share for the video with your friends, and make subscribe for the video to have any new video. Thanks for watching. See you later. Assalamu alaikum wa rahmatullahi wa barakatuh.